just kept the first one.
That one not working either?
Yeah.
Let me see that one. Hey, don't forget, Max, when it has that symbol up there, you cannot log in. Just hit the reset button on the back. What group is James in?
Over here.
Oh, you got him? You done answering the bell ring? Yes, it will. Follow the directions. By the way, make sure you manipulate the N is what you want to focus on. Alright, there. See how it has open hand? Hold till it closes.
Oh.
Okay, again guys, make sure you click on the N slider. When the hand is open, hold the center of D-pad down until that hand closes.
So, like, where's
The other two.
Did y'all hear? Mr. G, did you hear the two of the buses cut outside
It
from
was 3 total.
that?
In Inglewood.
Because it was like, they said something about a transformer thing, caught the grass on fire.
You know the
Not like a
Transformers aren't real, right?
They
Like,
said
the Autobots,
power lines
except no, they don't really fight each other, right?
No,
Yeah, the power line is snapped.
Come on, I'm talking about like.
No, we're not watching Transformers.
the power line
terrible
snapped
joke
in the brush inside it, and the brush united the transformer.
Hey, does this mean we all have an answer to this question up on the board?
I can't log in.
It won't.
Hey, Chelsea, have you tried resetting the calculator?
No, I'm saying like after I log in.
Oh, after you log in, if you don't open it, you can always go to your documents. I think it's number 2. Go to this class, and it'll be there in those documents.
Who is he, Doc? Oh. By the
What
brown?
is it called? What's it?
Was Zandy not here earlier? She was not, was she?
Can you explain the definition of power line?
We're gonna talk about that actually a little bit later. That's part of today's discussion. Was Jaden really here?
Huh?
There you are. Where's your phone?
Hey.
I was looking for Jaden here, and I didn't realize you were walking back there. All right, yeah, please, phones up. Thank you all for getting your cellular devices up. We haven't seen Bree today, is that right?
She
looked- oh, yeah,
hasn't used me for basketball.
Yeah,
It's
she's-
all excuse.
at Tuscaloosa thingy.
Oh, it's not really.
I guess it's her first.
All right. So let's get started looking at this. Actually, y'all got, well, yeah. So quick note about the agenda, right? So grading assignments tomorrow, just to help to make sure you're aware. One, I mean, I feel like I say this every day. Y'all know this. I have a kid. Life changed a lot in the last 3 weeks, but my wife has been a little stressed out. Had a lot going on. Just taking care of a 3-week-old. Apparently, not apparently, it is a lot. So I'm going to take tomorrow off while you take your test. When I'm not helping her, I am going to be working on getting all grades updated. Aiden's mom will be here to give you all the tests. There will be a non-calculator / short answer, 1 page, and then there will be a 1-page calculator portion. So you'll notice I've decreased it from 3 pages down to 2. I tried to make it more manageable time-wise. So knock it out. I'm trying to think of anything else with those details. Can you let Zanny in, please? But hopefully I should have all those assignments updated and graded tomorrow. It's hard getting everything done. Thank you. So let's look at this bell ringer, and then we're going to continue reviewing and practicing for our test. Deja already asked a good question about what is a polynomial, which means I should have done a better job of explaining this throughout the unit. Does anybody have, did I put that in here? Yeah. What do we mean by a polynomial? Polynomial functions. It's like, huh? So a polynomial literally does have multiple terms. Granted, I will say, like, we're looking at this function a times x to the n. Even though this only has 1 term, right? Right now, my a is 1, my x, and then raised to an n of 1. So we could also say that's x to the first. That's only one term, but this would still be within the family of functions known as polynomial functions. So what do we mean by polynomial functions? Okay, so it is a function, but there's lots of other types of functions. What are you saying, Kennedy?
The function, is it the one that has multiple terms?
It does have multiple terms, yes. Which I just thought of one detail I should have added in for first block that I'm just now realizing I didn't say. So these functions that we have been studying, like this, functions that look like this, these are polynomials. It would look something like this, right? Specifically, which polynomial is that? A cubic function, right? We can have just two, and then this would be a quadratic. So all of those functions that have x raised to a power, specifically it has to be a whole power. That's one of the things Ms. Essel talked about yesterday. All those functions that have x raised to a whole power, those are our polynomial functions. I would also point out that they are all the functions that are the product of linear and quadratic factors, right? So every polynomial can be broken down into those factors like that. The last detail I'll point out is this. Remember, a linear function had what type of rate of change? Constant, additive. What type of rate of change did a quadratic function have?
Linear additive.
That was the linear additive. What type of rate of change did a cubic have? Nope. Come on, think about it. X was constant additive. X squared was linear additive. X cubed is going to be quadratic additive.
What'd you do that for?
So if I have x to the fourth, this is known as a quartic function. It would have a cubic additive rate of change. So, polynomials. What do they all have in common? Yeah, your polynomial functions are the set of functions with additive rates of change. That's the big thing to note, right? So your polynomial functions are the functions with additive rates of change, right? They are the set of functions, right? So that it's x raised to a power, and you can have a coefficient on it, b times x to the power minus 1. So like if it was x cubed, the next option would be x squared, right? It keeps going. So your polynomial functions in standard form are always a variable raised to an exponent, a whole exponent, right? I'm not going to be testing you on that definition. That's my fault if I didn't clarify that earlier. But it is important to recognize that those are the polynomial functions, right? You've already been studying them. You've seen the graphs of polynomial functions this entire unit. You've been dilating polynomial functions this entire time. But that's what you want to notice, that the polynomials are the set of functions with additive rates of change. They're always a variable raised to a whole power, right? So that's something to be aware of. But the focus of this bell ringer is what we really need to pay attention to. Okay? This idea of polynomial, by the way, will come back up next unit. Don't stress it right now. We'll continue working with it. But I want you to look here. The question in the bell ringer was, as the multiplicity of a zero increases, what seems to be true about the polynomial's behavior around the x-intercept? Right now, we have x to the first. The next one would be x to the second, x to the third, and then fourth, so on and so forth, right? For every single one of these functions, what's the zero? X equals what? 0, right? Every single one of these, x is equal to 0. So what is changing about these functions? The zeros what? Same y-intercept too. Okay, but let me point this out. How many zeros does this function need? 2. But I only have x equals 0. This multiplicity would be 2, right? The multiplicity of this one would be 3. The multiplicity of this one would be 4. Okay? So when we're looking at this a times x to the n, right, this is a very special type of polynomial, we're seeing that the multiplicity is increasing, right, as we go through. So my question to you is, what is happening around the x-intercept, around that 0, when your multiplicity increases? So, look at n equals 1. As your n changes, make a conjecture, just any conjecture. What happens around the x-intercept as that multiplicity increases? I'll go through it one more time. And you can look at it on your own calculator if you want. Just come up with a conjecture. Okay, so, who has an idea? What's happening? Tristan? Okay, so Tristan was saying when n is odd, the n behavior is kind of going like this, whereas if it's even, it's going like this. Okay, can anyone clarify or add on to or push back on Tristan's statement? Alex? Okay, and so this is I'm going to go ahead and clarify in language here because this is an idea I've heard students say before. This does look like a cubic function, doesn't it? It has a similar shape to it. Is this cubic though? I mean, think about it. Cubic means it's x to the 3rd. This is x raised to the 9th. Does it have a similar shape to that cubic? 100%, but we don't want to call it a cubic. Does that make sense? In a similar way, does that look like a parabola?
Yeah.
Yes. But is it a parabola? Because parabolas only go with what type of function? X squared, a quadratic. Does that make sense? So I do want to know, like, it has a shape similar to a parabola, a shape similar to a cubic, but we do want to notice, and that's actually what I want you to focus on. What is different about these when that multiplicity increases, right? So here is, let's actually focus here. N equals 2. There's my parabola. These are all of those even degree polynomials. What's changing? Stretching it horizontally where? Around the, so we don't call it a vertex for a parabola, but what is this point right here? It's an x-intercept, right? So what I want you to notice is as that multiplicity increases, this almost gets wider and wider and wider. Does that make sense? That's the difference, right? When it's, and I will point this out, when it's an even multiplicity, what's it doing? It's coming down, it's touching the 0 and it's bouncing away, right? If it's ever an even multiplicity, it's going to come down, touch, and then bounce away, right? But what about when it's an odd multiplicity?
It's doing the dance.
What's going to happen if it's an odd multiplicity? It's going to go the opposite way, but think about what we were just saying with the even. Is it going to touch and then bounce away? It's going to go through it, right? It's going to go through. But again, is what y'all said a second ago true, that as the multiplicity increases, it almost widens out? Yeah.
What about when they all start at 1? Why are they always just 9? It's just 1.
So it's just going, well, part of the reason why that's happening is, if you think about this, and I think Ms. Essel even talked about this part yesterday, if you look at 1/2, if I take 1/2 and I raise it to the first, I just get y equals 1/2, right?
Yeah.
But if I have y equals x to the 9th, and I do 1/2 raised to the 9th, that gives me 1 divided by whatever 2 to the 9th is. So 1 divided by sorry, I'm thinking 32, 64, 128, 256. That one. That's like 0.004-ish, I think, somewhere in there. You see how like that 1/2 got really close to 0.
Yes.
That's why it's widening out, because when I raise a fraction to an exponent, it makes it smaller. Notice, is it actually a 0 here? A lot of students would be tempted to talk about this as an x-intercept and say that there's multiple x-intercepts, but there's actually only one x-intercept. All of this is just below the x-axis. It touches the x-axis and it's just above. Okay? But again, the main point I want you to notice is two things. One, if the multiplicity is odd, there goes the top. If the multiplicity is odd, it's going to do what through that x-intercept? It's going to go through it, right? If the multiplicity is even, it's going to bounce off of it. So this kind of does go into what you're going to study next unit, but those are things that we've seen within this unit that I did want to help clarify, because it's going to make graphing easier for you. Does that make sense? The other thing again is, as your multiplicity increases, what's going to happen at that x-intercept is almost going to stretch or widen out. So for example, these are just a quick sketch, and then we'll get started with the review that you have. If I had something like this, then what 0 would I have here? 2, x equals 2. So the x-intercept would be 2 comma 0. This would be an x-intercept of -1. And so for this one, it's going to come through because it's an odd multiplicity. And then it's going to come down, it's going to touch, and then bounce away because it's an even multiplicity. We'll go with that idea? Now, what happens if this slightly changes? Let's say that I make this a 4 and I make this a 3. Well, now it's not going to just come straight through, it's going to kind of flatten out and then come through. Right? It's going to change more than that, but you see how it comes through, it flattens out, comes back up. Similarly here, it is going to touch, but it's going to flatten out a little bit more and then go away. See how I just kind of, it's just a little bit, but it flattens out a little bit more. Let's say I jump this up to raised to the 9th. It's going to flatten out even more. Now notice this doesn't flatten out because I didn't change it. So very, very similar functions, but you see how increasing that multiplicity will just slightly stretch it. A cubic or an odd number of multiplicities always goes through, and even number touches and bounces away. Does that help us see some of the things we've been seeing on the graphs a little bit better, hopefully?
Can you repeat that?
Which part?
What you just said about the smaller or the...
So if it's an odd number of multiplicities, that part? So if it's an odd number of multiplicities, it's going to go through the x-intercept. And if it's an even number of multiplicities, it's going to touch and then bounce away. Does that make sense? Okay. So that's an important detail about those odd versus even numbers. And again, just as that multiplicity increases in general, it's going to widen around that x-intercept and almost look flat. I know it's exciting stuff, right, Grace Ann? Sorry for boring you so much. Okay. Really quickly, I do want to show you the correct answers for the first 4, and then we're going to jump into the actual review for today. You picked A, or you correctly identified A?
I identified.
You didn't just randomly pick it, I hope. All right. I'm sorry, I didn't realize you didn't want to talk to me. We're cool though. I'm just kidding, Jordan. Chill. Alright, any questions about number 1? Are we moving on? Going once?
Go over it.
What do I need to go over about it? Okay, but what about, so like, does anyone have an explanation for how I correctly determined it was A? Lexi?
Yeah, you find the zeros first, and then you can look at the graph, And there's like, you can see how it intersects -2 and then 1.
Yeah.
And those are your zeros and 8.
So two things. One, couldn't I just identify the zeros from these factors? Because the zeros are whenever the factor is equal to 0, right? That's where my x-intercepts are. That's a huge thing to notice. What you also could have done is just graphed each of those factors quickly. If I graph y equals x plus 2, which I don't like the fact that it's scaled by 2, but that's going down 2 to the left 2, so that's a slope of 1. So there's y equals x plus 2. You can graph negative x plus 1, so y-intercept of 1 and a slope of negative 1. And then negative 5x minus 1. Does that go through all the correct x-intercepts for that polynomial? Okay. So remember, I would probably do it algebraically, setting each factor equal to 0. But you can also graph them and determine, do each of those factors go through the correct x-intercepts? I mean, it depends on, not with what I've written right now, but the explanation with it or showing the rest of the work, right? But again, it's the idea that I know these factors have to give me those x-intercepts. That's the big one, the zeros. All right, any other questions? All right, here is number 2. All I did was quickly sketch it, which I'm now realizing it's in black, so it might be harder to see, but it's here. Ooh, that sound is not pretty. Yikes. Now, one thing I want to point out is this. Do you have to go as high as this or as low as this? No, you just have to have the positives or negatives in the right spot. Okay? Any questions about those?
Oh, that was the right.
Any questions? Dude, I hit the rim. I just, maybe one day I'll get better. I don't know. That would have been terrible. All right. Zane, you want to ask the whole class question, or you go just asking your group?
I was just asking, are we just graphing the line, we just graph because of the lines is already on? Like when we do the negatives and the positives?
So, say that one more time.
Like, draw the line we just done. We can get that line from looking at all the lines, seeing if it's negative or positive in between the zeros.
I'll address that in a second. I do want to push back on your language just a little bit. I want you to be careful. Does anyone know a word that Zany kept using to describe this that we want to be careful
A
about?
line, it's not.
Right. That's not a line, right? The curve, the polynomial, the cubic, any of those would work, right? But remember, I identify my x-intercepts because everywhere that's an x-intercept for the factors, that's an x-intercept for the resulting product function, right? But when I look at, what I'm literally doing is multiplying q of x times r of x. Q of x right here is above the x-axis, those are positive.
Okay.
R of x is below, so it's negative. And a positive times a negative gives me negative values increasing to that x-intercept. Does that make sense?
Yeah.
Yeah. So I'm literally looking at just, hey, these values are positive here, these are negative. When I multiply them, I get a negative.
Was 4 one of the zeros?
Say it again.
Was 4 one of the zeros?
Yes. Yeah. Because that's, so that, these two are the zeros or x-intercepts for the parabola. This is the zero or x-intercept for that linear function. You good with that? All right. We good? Going once? Going twice? Sold. All right, here's number 3.
Let's go.
What questions do you need to ask about this one? Number 3. All 3 of you. Yes, ma'am.
Oh, wait, no, number 3. I had a question for number 4.
Okay, we'll look at number 4 in a second. One quick detail I will point out here is this is what type of function again? It's cubic because it is what degree? 3. So it should have how many x, well, how many zeros? 3 zeros. Does it have 3 x-intercepts?
No. It only has two.
It only has two x-intercepts, but one of them has a multiplicity of 2. So when we count those multiplicities, it still has 3 zeros. We just would want to recognize, hey, it's only going to have two x-intercepts. Because of what we just talked about, we actually know at this x-intercept, what's it going to do? It's going to bounce off. It's going to touch and then bounce away, right? So those even multiplicities give us that case where it touches the x-axis and then bounces away. All right, any questions about that? One thing I will point out here is a question like this would definitely be on a calculator portion of the test. So how could you check part C?
You could grab that thing.
You could graph that standard form and do what else? And you would graph the factored form
And see if they map to
and
each
see if
other.
they map to each other. I like that mathematical language. Okay, here's number 4. I know that some of these details, this one's a little bit harder for some of us. Yes, ma'am.
Don't, okay, so you have to square root the x squared and the negative 1, right?
You do. So remember, if we're trying to find zeros, 0 is equal to x minus 3 times x squared plus 4, right? Zero product property. So that's where x equals 3, multiplicity of 1 comes from. Here though, negative 4 is equal to x squared. I have not finished solving for x yet. What do I need to do?
Square root.
I need to take a square root.
So that makes it just 8, right?
That's what would be the inverse of the square, making just an x.
And then 2 minus and positive.
Whenever you take a square root, you have to do a plus or a minus, which that should make sense because this is squared, it's quadratic, so it needs how many zeros? 2, right? And so I would rewrite this right away as 4 times negative 1 because then I can split it up into those 2 square roots, and square root of 4 is 2, square root of negative 1 is I. Remember, that was a big part of why we did last unit, is to get to those imaginary numbers. Yes, EK.
How is it a cubic function?
How is it cubic?
Yes.
So why did you think it wouldn't be a cubic? Let me ask that question first.
Because like all the cubic ones that we do, it has like 3 parentheses and this only has 2.
I know, but look at the previous one. Each of the factors were what type of functions in number 3? Would you say that each of those factors is linear? That you have linear and quadratic? What? They're each linear, right? And each linear factor is going to have 1 0 for a total of 3 zeros. Here, though, I have a linear and a quadratic. And the linear has 1 0. The quadratic has
It has
2 zeros for a total of 3 zeros. If there are 3 zeros, I know it is a third degree polynomial. Anybody know a really important theorem that tells us that relationship? Then, like, the name of that theorem is really, really important. It's kind of like fundamental to algebra. Fundamental theorem of algebra. Is that what you said? Sorry, Tristan was saying something too and I couldn't quite hear you. The whole thing is the degree matches the number of zeros. So the fact that I have 3 zeros right here, I know that I have a third degree
So
polynomial.
if there wasn't that like exponent on top, it would just be 2 zeros.
Correct.
So it would not be cubic.
Correct. Now, I will also point out, when you solve for those zeros, right? X equals 3, multiplicity of 1, right? But when you solve here, how many zeros did we get?
2.
2. So it's 3 zeros. Again, cubic. Does that make sense? Yes, Vanny.
So how did it get the standard form if you only have 1 exponent? Since the other
Well,
one is 2 imaginary.
Well, I mean, the number of zeros doesn't impact how we get to the standard form. What do we do with our factored form to get to standard form?
Distribute.
Distribute or use that area model to multiply. Right, so we get the standard form by just multiplying here. And you can either distribute or use that area model. You get with that idea? Okay. Any other questions before we get to the time where y'all get to practice? Just All right then. Fair enough.
Ooh, he told me it was unnecessary. What did I say?
Clay, why are you this way? Why are you trying to cause things? Why are you trying to cause things? That's fair. All right, let's move on. Here is number 5. I need y'all to hear me very clearly on this, and I need y'all full attention here because first of all, I sat there like half the groups were like super frustrated because they didn't listen to the instructions, even though we had one of these on the understanding check as well when we went over it there. Here's the thing. We are looking at g of x, right? G of x is the result of doing what with those 3 lines? We want factored form, and it talks about a product. It doesn't say the word dilate up here, but yes, we're doing dilations, right? We're multiplying. So if I want the factored form of g of x, where those lines are my factors, what do I need to do? I do need the x-intercept, so I'm going to caution you.
1, 2.
Hold on. Hold on. So what would you be tempted to put here based on this x-intercept? So we would need the opposite, right? X plus 2. Okay? What about here? What about here? X minus 6.
7.
Things 8.
8.
I'll tell you this. That function would have the correct zeros, but would be completely wrong. Huh? Yeah, those are lines. Did you actually write the equations of those lines yet? Okay. This would have the correct zeros, but you did not write the equations of those lines, so you would not get the product of those linear factors. So, what do you actually need to do?
Linear functions.
So what equation should we be thinking about if we're looking at a linear function? Thank you. All right, get to work on writing the equation of g of x, paying attention to the fact that we are multiplying those linear factors. Oh, really quickly, by the way, I do want to point this out again because I know it was literally designed for it, but yesterday when y'all were able to get up and move around the room, you had more fun, you were more engaged. You are always allowed when working to go to the whiteboards, to go to the chalkboards, erase what is there, and do your work there. Yes!
Oh, that's lit, okay.
That's why I have the chalkboards, okay? Get up, move around, show work, collaborate.
But y'all, from what I definitely.
Oh, like version of this? Yeah.
What?
Girl, hey, don't do that, girl. That's too much. Don't do that. I got.
Mr. Kidd.
Amari, do you need both pages or just that first page? Amari, both, just the first page?
They said cheerleaders wear. You not? You don't like those?
Hey, I don't like. So this one. They are here. Look at Steve. But we don't
I'll say you're very close.
For all of us, like,
You have 2 of them 100% correct. You are very close on one of them.
I can tell you which one. Oh, wait.
Your pencil. Sorry.
You saw me red.
Why do you look at it like that? Like not sure? Why? That would make sense, wouldn't it?
What is that?
Make sure, like, you count it, right, it's going down 3 and to the right 3. So negative 3 divided by 3. By the way, I would, right, so 3 divided by 3.
Yeah.
Or you want to do like
So it's negative 1x. Hey, by the way, when you finish number 5, or number 5, move on to 6 and 7 as well. Sounds good.
no, I got it. Just which one, right?
Sounds pretty good, right?
You got it for this one. What you saying about that?
You're not working with the volume.
You got already watched yours downstairs. Oh, I was just letting out suggestions. I wish I knew what I was doing.
Oh, you didn't count it? No, that's just a scale showing it
I
down.
don't have a paper.
But it's 1, 2.
Never mind.
Okay, let's look at the next one. Let's look at the next line. Yes, sir. Do what? Alright, what's the confusion?
Somebody just have to check on it, or he's gonna be like, maybe
Why is that?
Are we doing both of them?
Or y intersection. So y'all agree y equals 2 equals 2? How'd you get 2 at the bottom?
I thought it would be maybe.
Well, it can't be 1 and 2.
Well, I don't know. I just thought it was.
But don't just say.
But it seems like if
Did
you
you
do
go from here to here?
No, it's only if it's not.
No, you need to get that 2.
And you need to switch it.
But there's that's plus 2 and plus 2. What's 2 divided by 2? Notice it should be the same slope no matter what point you go to. But, right, rise and divide by 2.
Well, so the standard form, I guess, that is restricted.
you just
Say again. To get standard form, you do need the factor form first, and you are close on your factors. You need to check some of those equations. But yeah, you need to write in factor form. I can print out another one. Like you don't have any of the packet at all.
No, I had the 2 sheets we did yesterday, but I don't have that one.
So the review packet you don't have at all.
It was a packet? Wait.
Yeah, it's 2 pages. We're close. What do you use? What is the equation again? Y equals. What is B?
No, I just.
The B is the Y intersection.
Right, so it'd be like. I only have these 2 here.
Yeah, that's what this Estel gave. This is something I gave you all 2 days ago. No?
Oh wait, it might be in my book. Wait, don't print it off. Because I'll wait. Right there. Can you pass me that book over here?
Where did you get these? First off, I'm assuming that's true.
God's word is on the outside.
But, okay. So, how did you get this? Because the first thing I saw you do was take horizontal.
You know what I'm saying? Right here.
Rise is divided by run. The rise, I think, is 1. The run is 2. I would point this out. If you put 2 if you set that equal to 0, is that going to give you an x-intercept of 8?
Okay, I don't get high. Oh, geez.
That's why you're confused?
No.
Notice that would be 2, right? That would have next, but it's a 1/2 here. Check both your slope and your y-intercept. Jordan, you mean to print it out? Yes, ma'am.
You changed it.
Deja? I guess Deja doesn't even mean.
Yeah, I'll do it by myself. You
Hold on,
never
I'm
done it,
gonna
now you're
record it.
saying-
But hold on a second, Tristan. Do I want you to be doing all this on your own?
He's captain.
I want you to be actively collaborating.
You're captain so hard.
Hey, Jordan, you go.
She's always been a liar.
What's the like we found me the
Was the product of those three linear factors.
Right? I'm gonna be at G on you.
Is that my paper? Thank you.
Already on the
You answering a question.
Yes.
Why keep asking him what's the
But the good news is it doesn't change anything. So don't be scared of that fraction.
Oh, that hey. This is a smart. Girl, is it this one? Wait, what are we trying to do? I'm sorry. Ain't that like the H&A thing?
Oh, y'all added.
You're feeling good about writing the individual equations and
I think
Right.
I didn't find.
this is not important.
So, one thing to remember is, it looks like you're trying to do this times there as well. So you can only do those two.
It's actively.
I guess but so then you would take this.
What?
So like, I wrote down negative x squared times 1 3. That's like, that's what it is. Yeah, it's negative 1.
But I feel
But
like.
I mean, what's a negative times 1 half?
So it's
Negative 1 half. X
Negative
squared times x is x. Right? It's negative x squared.
Wait, because I don't understand.
Plus 4x squared.
You're not trying to bump, kid. You're not trying to bump, I promise you not. I'll flip it.
Plus 6 times a half is 3.
But yeah, negative.
I'm trying to figure out how to get
This one is like, this gets that's one of the reasons why I really tried to use that area model. But then you add your like terms.
Wait, what you said? Oh, yeah, let me come on. Come on.
But that's still good. A lot of things like this.
I just need to figure out what you
But I want you to look at that line, isn't that line decreasing?
How do you put it in
X plus 3 is coming from this y intercept. But notice, like, if I look at it, it's going down, so that'd be down 2 to the right zone. That slowed. Negative. Yes. I am about to get started.
I'm the real BFB.
I actually recommend doing this fraction.
This is standard basically real.
Like I would literally type out 1 half. Thank you. Thank you. Thank you. Thank you. I know we're still working, but I want to go ahead and grab a seat. We'll talk about this one just a little bit. And we just need to be careful. I think from what so y'all ended up getting there negative x plus 3 here. Just be aware, this y-intercept I think was a negative 4. Right? So, if I ever ask you to write the function that results from the product of those linear factors, you just need to write the equation of those linear factors first. Be careful though, because I see a lot of us get this slope wrong right here. Right? Go back and look. This is going down 1 and to the right 1. One thing I do want to point out is this. Does anyone see a detail that I add to my rise and run that most of you do not?
The arrows.
Those arrows. Why do I add those arrows?
Because it's one of them.
Because.
Which way is going?
Yeah, because which way it's going, it helps me remember if it's going down, it needs to be negative. If it's going up, it needs to be positive. If it's going to the right, positive. If it's to the left, it's
Negative.
Just take a second. Make sure you do your rise first. Right? Even take the extra time to write out m equals rise divided by run. Do your rise first, show the arrows to help make it harder to make mistakes. On top of the fact that that makes it harder to make mistakes, that also shows me more evidence of your understanding, which is important for that, scoring rubric. All right? Show me the clear evidence of your understanding. All right. So g of x is equal to, was it x plus 2 times negative x plus 3 times 1/2 x minus 4? Okay. And so that's what you should have there. What do we need to do to get standard form?
Distribute or multiply them all.
Distribute or, yeah, so really we need to multiply, and what are the options?
Distribute and do the area model.
I love that little area.
Okay. I think it's really helpful in staying organized, okay? I will remind you, I'm just going to jump to this step right here. This is what you should have after multiplying these two, okay? And so you would need to do a second area model or a second set of distribution, okay? And I know it drove some students crazy in first block that we had a fraction in there, because I know how much we love fractions.
And fractions make me happy.
Good, glad to hear it.
Psych.
I know. Man, only you're as funny as you think you are.
That was funny.
Thanks. Okay, so you just distribute like normal. Don't make it harder than it has to be. What's a negative times 1/2? Negative 1/2. X squared times x is x cubed. Yeah, to the third.
Be for real.
Negative x squared times negative 4 is 4x squared. Then we get a 1/2 x squared. Negative 4x, 3x, and negative 24. The only time here that we actually have to add a fraction and a whole number is right here. And Grace Ann was asking about this. So first off, you could just do this as a decimal. Literally, that's 4 plus 1/2, right? 4 plus 0.5 or 4.5. But pick up your calculator for me really quickly. And I want you to type in 4 plus 1/2 in the calculator. Type it in exactly like that. As soon as you do, hit enter.
4 plus 1/2.
Well, but 9/2, right? So your calculator will add fractions. I wholeheartedly recommend leaving your answers in fractions because if you ever get to the point of calculus, you will want fractions and not decimals. I guarantee you that you want fractions instead of decimals. So you just leave this as negative 1/2 x cubed plus 9/2 x squared plus, minus x minus 24. What is that, g of x? By the way, guys, don't ever forget to put g of x or f of x or whatever at the front because it is a function. But that's my answer. Alright, questions, comments, concerns about those details? Yes, Zany.
Keith, if you put 4 in 1/2, is that okay? Instead of 9 and 2?
Like, as a mixed number? No. You can do 4.5 as a decimal, or you can do 9/2. Do not use mixed numbers. Yeah. That's a standard mathematical thing because that really can cause you errors later on down the line, so don't do that just because it'll mess you up in the future. Lexi, did you have your hand up?
Yeah, I was wondering, I don't know what to compare it to, but it kind of reminded me, whenever you're doing 4 plus 1/2, I was thinking 4 1/2.
Yeah.
Or, so that's how you do it, but then I was like, wait, that could be wrong, and then I was thinking,
I mean,
multiply it, but you didn't have it.
4, it's literally 4 plus 1/2. That is equivalent to the mixed number 4.5, but which is why you can write that as 4.5.
Yeah.
But it's better to write as a fraction. The way that the calculator is getting 9/2 is it's creating a common denominator. So we have 8/2. That's the same as 4 plus 1/2 is 9/2. But you don't have to do that by hand. Just let the calculator do that work for you.
Or can't you do, the 2 times 4 and then plus 1? That's how I learned it in
Yeah. So isn't that what this is doing though? times 2 plus 1. This is the mathematical reason why that works. Because if you think about 4.5, what that actually means is 4 plus another half. That's why you can do 4 times 2 is because you're creating that common denominator. You hadn't learned that yet when they taught you how to convert it to an improper fraction. That's where that came from. Because I actually thought about that a couple years ago. I was like, why do they do that? Oh, because they haven't learned how to do 4 plus 1/2 yet. Yeah. All right. Last questions about this before we look at the graph for number 7? Okay. So when I go to graph the product of these functions, to graph this polynomial, which could also be written like this, what am I going to do? How am I going to graph for number 7?
Use a zero product.
Now, so that's a good point, right? Find the x's first, find the zero, use the zero product property, but remember I've already been given the graphs, right?
So then look at the lines.
Yeah.
And do all the-
Right, like if I've already been given the graphs, guys, I don't have to do any of the work to find the x-intercepts because they're already there. I'm just going to use these x-intercepts. Right? If I just gave you the equation, you might need to find the x-intercepts, but I already have them. So what's going to happen to start?
It's gonna be going down.
So it's going to start at the positives, go down to the x-intercept? Is that what you're thinking? You said it's going down? Anybody want to push back on or ask a question about that? Negative times negative times positive is positive, isn't it? Oh yeah, you might want to be careful. Alright, so then after that it's going to what? Is it going to bounce or is it going to go through?
It's gonna go through.
How do you know it's going to go through?
Because you have two positives and positives.
So a positive times a negative is a negative, right? Also, I'll point this out. I gotta come back up to that 0. Is that an odd root or an even? Or is that an odd multiplicity or an even multiplicity? It's only one root, isn't it? So it's an odd multiplicity, so it's got to go through. And it comes over to here. Is it going through or is it going to bounce? Bounce that?
It's gonna go through.
Why is it going through, Lexi?
Because you have 2 negatives and a positive.
So notice Lexi keeps going back to these factors here, and that's a great strategy. What's a positive times a negative times a negative? That's a positive. So it's going to be going to the positive and then come back down to that 0. But again, think about it. There's only one linear factor here, right? So is that an even or odd multiplicity? Odd. So it's got to go through. It's got to go through. That's what I want y'all to start to notice. That's why I had that bell ringer to help you understand when it bounces versus when it goes through. Pay attention to the multiplicity there. All right? What's this going to do? It's an odd multiplicity, right? So it's got to go through. Be careful and do note, this line does continue. So it's a positive times a negative. There's 3 linear factors, so you should always have 3 signs that you're multiplying. Okay? There's your cubic. Final questions. We're going to skip numbers 8 through whatever. Because I decided to take one like that off the test.
So 7,
We just did 7.
no,
Sketch the graph.
I meant to say 8.
Yeah.
So we're skipping which one, 8 through what?
We're just going to 8 through 11, really.
So
The only thing about this, remember, the fundamental theorem of algebra says that the degree matches the number of zeros, right? If we see it right here, what degree is g of x here? 3 linear factors, so 3 zeros, so degree 3, right? Okay? But here, and that's all I wanted to recognize about the fundamental theorem. Yeah, I'm skipping number 8. It takes a little bit of time to write the equation at quadratic, and it's good. We'll bring it back later. We just don't have time for it right now. All right, let's look at the next page, number 12 through 15. I've already given you a graph. I want you to take the next, 5 to 8 minutes answer every single one of these that you can. There was one of these that everyone in first block, or no one in first block knew, that's fine, skip it. If you struggle with some detail, we'll go over these things, but do your best to collaborate and come up with an answer as a group for all 4 of these. All right, so work together, number 12. What do you think the domain and range is of this function? What do you think the intercepts are, the domain intervals of increase, decrease, all that kind of stuff. All right, we ready? And work. That's it. Let's go try the connection, but not quite. So focus on what you know quickly and easily. No idea? Anybody? Okay, so one of the things I will point out to help keep
Obviously,
these,
we don't know.
keep them straight. The way I always keep them straight is it's alphabetical. X and then Y, right? Alphabetically, what comes first, domain or range? Domain is your X, your left, right. Range is your No, so it's the domain and range of the entire function. Kind of. So like you say of each point has your but like you gotta remember there's a point right here. Even though like I didn't put that a point like that. The reason why it's a smooth curve is because you go point right here, and here, and here, and here. It keeps going forever. It's infinitely many points. So what we're asking is what are all those x values? You can't write out all those points. But you said the lowest and highest, right? Maximum, minimum. So like when I think about domain, what is the minimum? What is the lowest x value for this -4 to 0? There's no x values to the left of that? Well, it's the end of this curve. Okay, why do you say negative? Be careful, not mine. Remember, this keeps going up, but as it goes up, it also goes to the left. Is it ever going to stop going up and to the left? No.
No,
So what is the lowest? And we put, the way we typically write is what's called interval notation. We put a comma in between the minimum and maximum. And I'll explain more about parentheses versus brackets later. Is that the highest Y value for the entire graph?
Wait, so this is the domain and range?
That's just domain. Because remember, that's we only looked left and right, just the x
So
values.
range is like to be vertical?
Vertically, up and down.
No,
to go.
what?
Let's go.
Okay, that's good. Okay, so
Infinite, positive, or
just can you explain?
Well, then, if you don't know, skip it. Remember I told you, answer everything you know, right? But we'll point out tomorrow, you already have x-intercepts and relative maximum done, and they haven't even looked at that yet. We could be collaborating.
No, I'm not. I'm still on the range number 12. I did it already.
Oh, gosh.
Oh, they're both going up, so it would be negative 72.82.
So what are y'all doing right now?
So the range
Okay, that's your pencil real quick. I want you all to pay attention to this, because it looks like you're writing these x values, right? Well, they are. That's what it looks like. That's what Juan's doing, and what Chelsea's doing, and that's what you're doing too, right? Are you even working with them? They're all on the same
I
page.
just asked them why they did it.
Look, here's the thing. All you did was look at these individual points. But isn't this an understood point right here on the curve? Right here. The reason, though, I need you to understand, the reason this curve exists is because there's infinitely many points, and when we put all those points together, it's going to create that curve. Can you write out infinitely many points? No. That's why we use something that's called interval notation. Right. That's the point of interval notation, that I can't, there's infinitely many points here, I can't write them all out. But it's not, I'll say this, it's not always negative infinity to infinity. You need to think about what is the minimum